DE220084. For this group, we have 6 members and we from group 4 section 4. For this video, we will present the group project about characteristic and efficiency analysis of an induction motor. Let's go. Hi, Assalamualaikum. My name is Muhammad Faiz Farhan Meroazam and my metric number is DE220084. So now, I want to present about introduction. The aim of this project is to investigate and analysis the characteristic and efficiency of an induction motor. Okay, induction motor are widely used in various industry and application due to their robustness, reliability and cost effectiveness. Induction motor work on the principle of electromagnetic induction and are commonly used in industrial setting for tasks. Within the scope of this research is a demonstration of a MATLAB model of an induction motor that use a rotor as it is reference point during the course of this project. We will demonstrate the primary capabilities and characteristics of an induction motor while it is operating in a simulator. The report will also provide a plot of the induction motor torque speed, characteristic and power speed, the amount of extra resistance required to map the induction motor torque speed characteristic and the number of resistors. The rotor needs to attain its maximum torque. Additionally, this report will indicate the number of resistors required by the rotor to achieve maximum torque. So now, we go to the next present. Thank you.
Assalamualaikum, my name is Muhammad Zulkifli. So right now I will present about our group methodology and we will start with the flowchart of this group project. So for starter, we create a group consisting of 6 members, and after every member agreed to join, we discuss and divide the workload between all the members. And after all the members agreed to take on the workload, we proceed to code the necessary sequence using MATLAB, which is handled by Fazul Hadi and Ismail Arif. So after testing all the codes and obtaining the results, we will write a report based on the obtained results. So for the next part is the block diagram. So as you can see, physical or software process can be anything. So our group built an induction motor to test its efficiency and characteristic for the job. This project uses software MATLAB to investigate induction motor characteristic and efficiency. So the code generates torque speed and power speed results. MATLAB code generated some of these values which engineers, scientists, and students, including college engineering students, can program with this app. So this program examines and creates future useful systems and goods. Matrix-based computational mathematics is required. So induction motor primary properties requires a series of operations. The motor's rated voltage, numbers of pole, rated HP, and impedance are set first using speed, voltage, current, and a motor model. These numbers can be calculated. Second, Thevenin equivalent voltage and impedance are calculated using the parameters. MATLAB receives the selected parameters and synchronous speeds. So for the next part, the slip is changed from 1 to 0 in 0.01 increments to calculate torque and power. So for the next part, we will examine the induction torque speed and power speed. And lastly, MATLAB plots motors and examines their starting torque, pull-up torque, and pull-out torque, as well as their speed. So MATLAB can compute the torque speed characteristic curve of an induction motor by first identifying its physical characteristics and then creating an analogous circuit model based on them. So the model is used to derive the Thevenin equivalent circuit, which is used to calculate the torque speed characteristic curve, which then MATLAB code plots torque speed characteristic curve. So based on open circuits and block rotor test, MATLAB can calculate the equivalent circuits of a 3-phase induction motor. So as you can see, industrial application use induction motor due to their simplicity, dependability, and efficiency. So, to maximize performance and efficiency, the motor's behavior must be examined under various operating conditions. Induction motor models undergo steady state, dynamic, efficiency, and fault analysis. So, that's all from me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadlan Hazim bin Khairul Fazilah. My metric number is DE220105. I will continue present about methodology. Okay. In addition, induction motor models begin with steady state analysis. This examination examines the motor's steady state characteristic under constant speed and load. The steady state analysis calculate torque, speed, current and power factor to assess motor performance. Dynamic analysis analyze an induction motor model. Motor starting, acceleration, deceleration and rapid load change are examined in this analysis. Dynamic analysis examines the motor response to input voltage, load, torque and speed to guarantee dependable functioning. The efficiency study will analyze an induction motor model next. This study calculates motor efficiency defined as output power or input power. And input power efficiency analysis calculates motor losses to evaluate energy efficiency. Mechanical, copper and iron losses occur. Defect analysis also involve induction motor modeling. This inquiry finds and characteristic motor issues, bearing failures, short circuit, open circuit, unbalanced voltage. Fault analysis analyze motor performance, waveforms and fault signatures to find and correct motor issues. Induction motor models can be studied utilizing simulation-based testing, analytic modeling, computation of motor parameters, traction modeling, and numerous analysis techniques. These strategies can optimize motor design and operation for maximum efficiency and performance. That's all from me. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzahan bin Marjahan with the metric number DE220147. Now, I'll explain about the result and discussion, which is about the calculation question that had been given from this instruction report. So, the first one, we need to find the Thevenin equivalent voltage. So, firstly, we need to find the V phase with the formula. The rated voltage that we set, which is 460 volt, will divided by square root of 3, and we will get the value of V phase is 265.58 volt. While for the equivalent voltage, we need to use formula XM over X1 plus XM and then multiple by V phase that had been calculated at here. So our XM that we set, which is J30, and then divided by our X1 that we set, which is J0.41 plus J30 our XM, and multiple by our V phase that we had been calculate, and our equivalent voltage is 262 volt. So the second question that we need to do, where we need to find the Thevenin equivalent impedance. So our RTH equal to R1 multiple by XM over X1 plus XM the power of 2. So our R1 that we set, which is 0.20 ohm, and our XM J30, our X1 is 0.41 and plus J30 as power of 2, and we will get the equivalent impedance is 0.195 ohm. So next, the next question is we need to find how much additional resistance would it be thought occur at the starting condition. So our S max is 1.0 that we set. So our XTH is same as X1 that we set, which is 0.410, and this is the formula of S max, and then we rearrange it to find the value of R2. After that, we insert the value of S max, our RTH, our XTH, and X2, and we will get our value of R2 is 1.245 ohm. So to find the additional resistance is the value that we get, we need to minus with R2 that we set, which is 0.120, and the additional resistance is 1.125 ohm. And our synchronous speed, we need to use formula 120 multiple by frequency and divide by poles. So our frequency is 50 Hz. 50 Hz. It is a common frequency in Malaysia, and divide by poles that we set, which is 4, and we will get the value synchronous speed is 1500 rotation per minute. Lastly, our synchronous speed in rad per second, we need to use formula of this, and then we put the value of and synchronous speed that we had been calculated, and we will get the value is 157.080 radian per second as our synchronous speed in radian per second. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Arif bin Hadi. So I'm going to present our simulation on the induction motor. So this is the MATLAB code for the induced torque for the motor. So this is the parameter of the motor, which is R1, X1, R2, X2, and also Xn. So now we run the code. As we can see here, this is the graph of induced torque versus motor speed in RPM. So we plot here, this is the starting torque, which is 98.21 Newton meter at 0 RPM. So we're moving to the maximum torque, or the pull out torque, which is 456 Newton meter at 1350 RPM. So now we're moving to the power of the motor. So this is the MATLAB code for the power, which you can see the difference is the formula here, which is P out or P conf, which is induced torque times with the motor speed. So if we run the simulation, we can see the graph here. So this is a graph of power output power in kilowatt versus motor speed in RPM. So we can plot the graph here. So at the speed 0 RPM, we can see the power of the motor is 15 kilowatt. And we are moving to the maximum power. Here we can see about 71 kilowatt at 1360 RPM. So for the next question is the induced torque, but we need to make the maximum induced torque occur at 0 RPM. So from the calculation, we have achieved calculated the resistance value of rotor circuit that needed to change the relationship of the induced torque. So this is the original resistance of rotor circuit. Now we change to the calculated value, which is 1.245 ohm. So when we change the parameter here, we can run again. So we can see the difference of graph of induced torque versus rotation of the motor speed in RPM. So we can see here the starting torque here is the maximum torque, which is 456 Newton meter at 0 RPM, and it continue until reach 1500 RPM, which is the top until 0 Newton meter. Now for the next question, which is the plot of induced torque at slip 0.2, the converted power output, also the efficiency of the motor. So this is the code, and this is the part of the result that we want to simulate. So we run the simulation. So this is the induction motor torque speed for slip 0 to 20% or 0.2 slip. So this is the at 1200 RPM, the induced torque is 456 Newton meter until 0 Newton meter at 1500 RPM. So now the figure 5, which is output power. The converted power. So the graph is converted power versus motor speed in RPM. So at 1200 RPM, the converted power is 46 kilowatt, and into the maximum converted power at about 1371 RPM. So the converted power is about 65 kilowatt. This is figure 6, which is the output power. Output power is the converted power minus with the power loss in the induction motor, which is called losses, mechanical losses, and also miscellaneous loss. So this is the output power at 1200 RPM, which is 45.5 kilowatt, and maximum power output is about 64 kilowatt at 1383 RPM. So lastly, this is the efficiency graph of the motor. Okay, this is at 1200 RPM, the efficiency is 58%, and we move to the maximum efficiency of this motor is at about 92.6% of efficiency at about 1479 RPM. So this is the graph of our efficiency of the induction motor.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So as a conclusion from this group project, we had explored the main characteristic and efficiency of an induction motor during its operation with load changes in simulation environment, which we use the MATLAB to simulate the induction motor model. So from the chosen parameters and synchronous speed, then we calculated the Thevenin voltage and impedance in order to calculate the main characteristic of an induction motor. So from the MATLAB simulation, we learn how to plot the graph, which we already plot the graph of torque speed and power speed characteristic graph of an induction motor in the MATLAB environment. So we also prepared the newsletter which contain our findings and analysis of induction motor. So in conclusion, we are able to demonstrate the main characteristic and efficiency of an induction motor using the theoretical concept that we also applied in MATLAB environment as simulation. That's all from me. Thank you.